Let us discuss electrochemical cells. Electrochemical cells are those cells in which chemical energy is converted to electrical energy. Electrochemical cells can be divided into two types: primary cells and secondary cells. Primary cells are those cells which cannot be recharged, whereas secondary cells are those cells which can be recharged. Example for primary cells are Daniel cell, dry cell, etc. Daniel cell, though it is a reversible cell, it is not a rechargeable cell. Reversibility means if you apply potential greater than 1.1 volt, the direction of current can be reversed. Means Zn2 plus generally during when electricity is produced, Zn metal is converted to Zn2 plus. When you send a reverse current, Zn2 plus can transform to Zn metal. But this happens only with the infinitesimally small current density. If you send very high current, reversible current, uh, instead of Zn2 plus getting reduced to zinc metal, the H plus hydrogen H plus from aqueous solution is transformed to hydrogen gas. So hydrogen liberation reaction happens in Daniel cell if you send high charging current. So Daniel cell is not a rechargeable cell, though it is a reversible cell. It cannot be recharged because hydrogen liberation happens instead of Zn2 plus convert back to zinc metal. Dry cell is also a primary cell. Here also zinc metal is there, so we cannot recharge, we cannot convert Zn metal back to zinc metal here also because aqueous solutions are there. So if you try to recharge a dry cell, hydrogen evolution happens and the cell may explode. Alkaline battery is also a form of another kind of dry cell. Here zinc metal is used in the form of powder. Instead of using the acidic electrolyte like ammonium chloride, in alkaline battery, KOH solution is used as electrolyte. So this type of cell is having very low internal resistance. Alkaline battery is having very low internal resistance, so we can draw very high current because we use zinc metal in the form of powder here. And this type of battery is also having same EMF that of dry cell 1.5 volt. This two type of cells are available in market, dry cell, ordinary dry cell as well as alkaline cell, both having same EMF. Particularly we use this type of alkaline battery in power toys where we require very high discharge rate, very high current. Lithium cell. Lithium cell, you might have seen button type of cell found in watches. This here lithium metal is used. The cell has EMF about 3 volt. This cell has a long life uh, and high energy density. That's why we use lithium cells in watches. Let us see secondary cells. Secondary cells are those cells which can be recharged. Example for secondary cell is lead acid battery. Lead acid battery has been using from 19th century. Consists of two sets of lead plates. Each lead plate is coated with lead sulfate precipitate. Lead metal is coated with lead sulfate precipitate, and which is dipped in 20% sulfuric acid solution. On charging, negative plate lead sulfate is converted to lead spongy lead or lead powder, metal powder. Uh, the positive plate lead sulfate is converted to PbO2. Uh, the important drawback of lead acid battery is that it has very low energy density. The battery is very heavy, and the cyclic life is also less. It can be used only for 1000 cycles of charging and recharging. Why this battery is having low cyclic life? It is because positive electrode usually get eroded, and so the plate area of positive plate decreases with the time, and also lead sulfate, in the amorphous form is the active material, has tendency to convert into crystalline form, more stable crystalline form, so which is not an active material. Crystalline lead sulfate is not an active material. Therefore, as time passes, the amorphous lead sulfate is slowly transformed to crystalline form, and the energy density of the battery decreases with the time. Nickel cadmium batteries, lead acid battery is having EMF about 2 volt. Each cell is having about 2 volt EMF. Nickel cadmium batteries was used before 10, I think about 20 years back. This type of battery is not there in market now. This battery is having EMF about 1.2 volt. It has very low internal resistance. We can draw very high current from the such nickel cadmium battery, though the voltage is only 1.2 volt. This type of battery was used uh, very high discharge rate is required. Nowadays, with the advancement of lithium-ion battery, this battery is not using now. Nickel metal hydride battery was used in first generation mobile phones. Uh, the mobile phones which come out of market in 1998 were made out of nickel metal hydride battery. The development of lithium ion battery started in the year 1990s, and lithium ion battery is more promising one, and nowadays widely used in mobile phones, laptops, and also in uh, electrical vehicles. Let us see the construction of lithium-ion battery in next slide. Lithium has higher negative value of reduction potential. Lithium has high negative value of reduction potential. The E0 value of lithium is minus 3.05 volt, is most negative value, is the lowest, having highest negative value when compared with the other metals. Even potassium or sodium is not having such a low negative value. It is because lithium ion is a smaller ion. It has very hydration energy. So that's why EMF is low, even highly negative, when even lower than that of sodium or potassium, because of high hydration energy due to smaller size of lithium plus. The atomic mass of lithium is only 6.94. So 6.94 gram of lithium is needed to provide only 1 mole of electrons. 1 mole of electron is having charge of 1 farad of electricity. Let us see the construction. The negative plate is graphite. The copper electrode just acts as a contact electrode. There is a separator and electrolyte. Electrolyte is usually lithium salt, particularly LiPF6, dissolved in organic solvent like ether. Here we will not use aqueous solvents because lithium is highly reactive with the aqueous system. So organic electrolytes are used. Another active material is lithium cobalt oxide. The positive electrode is made up of lithium cobalt oxide. The aluminum electrode just serving as a contact electrode. And this is the construction. So graphite is the negative electrode, and lithium cobalt oxide is a positive electrode. The electrolyte is lithium salt dissolved in organic solvent like ether. We can have polymer electrolytes also. A polymer, for example, sulfonic acid of benzene sulfonic. For example, if you have a polymer with the benzene rings, the benzene rings are sulfonated. You have SO3H group, and the H plus is replaced. When you replace H plus with the lithium ions, the negative part of the polymer SO3 minus is fixed to the polymer network, and only lithium ions is mobile. So Li plus is freely move through the polymer chain, and such type of polymers also used as electrolytes in modern lithium-ion batteries. Let us see the chemistry of anode material. Anode material is lithium cobalt oxide. Let us see how lithium cobalt oxide is synthesized. Lithium cobalt oxide can be synthesized by taking lithium chloride and cobalt chloride in a hydrothermal reactor. Heat the lithium chloride and cobalt chloride under high steam pressure. We can co-precipitate lithium oxide and cobalt oxide together as a single lattice. So lithium oxide, in lithium oxide, lithium is in +1 oxide state, cobalt oxide is CO2O3, cobalt is in +3 oxide state. So we can regard it as a mixer oxide. So if you sum up to lithium oxide and cobalt oxide, you get Li2, CO2, O4. O4 come because O3 plus O gives O4. You divide by 2, you get LiCO O2. O4 become O2 if you divide by 2. So this is a simple formula of lithium cobalt oxide. So this crystal is made out of oxygen O2 minus array, O2 minus array, and where lattice points are occupied by face-centered lattice points are occupied by face-centered cubic lattice points are occupied by oxide array, and lithium plus and cobalt 3 plus ions are occupying in the octahedral void and tetrahedral voids respectively. The lithium ions occupies is a smaller ion occupies the tetrahedral void. Cobalt 3 plus occupies the octahedral voids, and O2 minus forms oxide array, and this is the anode material. Here lithium ion can be removed from the lattice points, the latticite that we'll discuss here further. Lithium cathode material is graphite. Electrolyte is salt of lithium like LiPF6, Li plus PF6 minus, or Li plus BF4 minus dissolved in organic solvent like ether. Let us see the charging process. During charging, the cell acts as an electrolytic cell. But in the case of lithium ion battery, we have to start with the charging process, and the anode material. Anode is positive in electrolytic cell. Anode is positive electrode in electrolytic cell. So anode during charging, oxidation happens at anode. So lithium, cobalt oxide, some lattice points, lithium atoms are removed. Not all lithium atoms are removed. Only 90% of lithium atom from this lattice is removed during charging. So 90% means 0.9. So Li, so it become Li 1 minus X, where X is 0.9, usually 0.9, 90%. So Li 1 minus X, COO2 is obtained. Some lithium atoms are there in the lattice. So lithium atoms are removed from the crystal lattice, and lithium ions are removed from the crystal. It comes out as Li plus X electron. Here the cobalt 3 plus oxide. Here cobalt is in plus 3 oxide state and lithium is plus 1 oxide state. Here when lithium atoms are when lithium ions are removed from the crystal lattice, the corresponding site in the cobalt in the lattice has to oxidize from plus 3 to plus 4 oxide state in order to maintain the electrical neutrality. So cobalt has to oxidize from plus 3 to plus 4 in the corresponding lattice site. So the electrical neutrality is maintained. This XLi plus produced from the crystal lattice get transported through the electrolyte and comes to the graphite electrode. When it reaches the graphite electrode, a reduction happens. Since the graphite electrode is provided with a negative sign, and electrons are added, and lithium atoms are generated. These lithium atoms are inserted between the graphite layers. So Cg is graphite. So lithium ions transported through the electrolyte. Lithium ions are produced on the crystal lattice here, get transported through the electrolyte, and reaches the cathodic layer, graphitic region, and where lithium ions are get reduced to lithium atoms and get inserted between the graphitic layers. Let us see the where here X is less than 1 mole is very important thing. X is must be less than 1 mole, and let us see if some lithium ions get removed from the crystal lattice, and the respective lattice site cobalt 3 plus ion get oxidized to cobalt 4 plus, and electrical neutrality is maintained in the lattice. Let's see the next slide. During discharging, the reverse of the charging process happens. If you know the charging reactions, you need not study the discharging process. If you just the positive electrode, the reverse of this reaction happens. Just put the arrow in the reverse direction. So Li 1 minus X CO2 plus XI plus X electron gives Li CO2. This reverse reaction happens, and the positive electrode is is cathode in discharging process, because during discharging the cell act as electrochemical cell, means electrical chemical energy is converted to electrical energy, and you have to take the reverse order. Similarly, the negative electrode is anode, where lithium atoms from the graphitic layers get removed from the graphitic layers and get oxidized to lithium plus and electrons, and this lithium ion produced here get transported, and see the let us see the discharging reaction. So the lithium with the reverse of this reaction, cathode, the positive electrode becomes cathode and negative electrode become anode, and the reverse of the reactions happen. So we have to start from here actually. So lithium atoms inserted between the graphite layers are removed from the graphite, and lithium ions are generated plus X electrons. So this is the negative electrodes because the electrons are generated here, and this lithium ions produced here get transported through the electrolyte and reaches the lithium cobalt oxide crystal surface, and where lithium ions are inserted into the crystal lattice and converted back to lithium cobalt oxide. This is the discharging reaction. And here one important thing is that lithiated graphite is written as LiXCg and containing no lithium metal as such. There is no lithium metal here. That's why lithium ion battery is not called lithium battery. Lithium metal is not there, only lithium ions are there in the battery. Lithium atoms are there inserted between the lattice. There is no lithium metal. If you use lithium metal, the problem is that instead of graphite, if you use lithium metal, the problem is that there will be dendritic growth. Spongy precipitate of lithium metal is formed at the formed at the lithium metal surface, and this leads to short circuit, internal short circuit of the battery. So that's why we are not using lithium metal. Rather, we use graphite electrode, where the lithium metal is not formed, only atoms of lithium. Lithium LiCg is lithiated graphite is produced during charging process. Let us see the chemistry here. When lithium ions are here, lithium ion cells are not allowed to charge completely. When lithium ion cells are allowed to charge completely, X become 1. So anodic material become Li1 minus 1. Li1 minus X become Li1 minus X CO 1 minus 1 COO2, or we can say Li1 minus 1 is 0. So lithium, there won't be any lithium atom there. So it becomes COO2, which is an explosive material due to liberation of oxygen gas. COO2 cobalt is in plus 4 oxidation state. So that's why we will not allow the lithium ion battery to charge 100%. So automatic built-in circuits are there inside a battery which allow charging only up to 90%, X equal to 0.9. So there must be a breaker circuit which will not allow complete 100% removal of lithium ion from the crystal lattice. That is very much important, lithium ion battery. And let us back to the previous slide. See, this is a crystal lattice of lithium cobalt oxide. Here the green colored one is lithium ions, and which is during charging process, which is transported through the electrolyte and reaches the graphitic layers. The lithium ions get transport the graphite layers, where it is inserted between the graphitic layers, and electrons are produced here because of the conversion of cobalt 3 plus to cobalt 4 plus, and this electrons oxidation process, electrons are generated here, and during the reduction process, when lithium atoms are inserted, it accepts electron from the electrode, and that reduction happens. Let us see the remaining slides. Let us see the different aspects of lithium battery. There can be different type of anodic materials. Now large developments have been taking place. Lithium cobalt oxide has battery has and graphite anodic material has lithium cobalt oxide is the anodic material, and graphite is the cathodic material in conventional lithium ion battery, which can provide about 3.7 volt. You know, your mobile phone battery is having voltage of 3.7, and it has gravimetric capacity 140 milliampere hour per gram material. Per gram it can give 140 milliampere hour per gram. This is the energy density of the battery. If you use lithium, instead of lithium cobalt oxide, we can have lithium manganese oxide, where we get here lithium plus ion and Mn 3 plus ion is there, and voltage we get is 4 volt, and the gravimetric capacity is only 100. And lithium nickel oxide battery is another promising one, which can be used in various applications. Nickel oxide is having potential of 3.5 volt, and the gravimetric capacity is 180. Is high gravimetric capacity than even lithium cobalt oxide battery. Lithium iron phosphate battery. Lithium iron phosphate is having potential only 3.3 volt, but the gravimetric capacity 180, 150 milliampere hour per gram. Lithium iron phosphate is promising material which can be used in electrical vehicle, because lithium iron phosphate is more stable. It won't explode. It's not an explosive material. So lithium cobalt oxide cannot be used for making automobile battery, because automobile battery, electrical vehicles is a large size battery. If it explodes, it can explode like a RDX, which can kill people. So the lithium iron phosphate is not an explosive material. So this battery is using in automobile electrical vehicle batteries. Let us see the different type of cathodic material possible. Most popular cathodic material is graphite. Every 6 carbon atom of graphite can accommodate a lithium atom. Another anodic cathodic material like lithium titanate. Lithium titanate can be used as a material which can take up lithium ion instead of graphite. So here lithium titanate, lithium is in plus 1 oxide state, titanium is in plus 3 oxide. If we completely accept lithium atoms, we get titanium in plus 3 oxide state. When lithium atoms are removed from the crystal lattice, titanium from plus 3 go back to more stable titanium 4 plus. So this type of material is also a promising material for electrical vehicle battery. The advantage of lithium titanate is that the cyclic life can go up to 20,000 cycles of charging and discharging. So this type of materials are required for developing electrical vehicle battery. So this type of batteries can be have life about more than 20 years. Recently, KMML, Kerala Minerals and Metals, signed an MOU with the Toshiba battery company from Japan for the development of for the production of lithium titanate material. The company will soon launch the production of lithium titanate material for electrical vehicle application. Another materials which can be used, hard carbon can be used, tin cobalt alloy can be used, silicon carbon nanomaterials can be used as uh, cathodic materials, which are also under development. So large number of developments happens in the field of lithium-ion battery, and large amount of researches are going on, particularly in the field of electrical vehicles. You know, the heat engine technology is will come uh, will uh, will soon come to an end with the development of new kind of batteries like lithium-ion battery. Uh, Vehicles will soon transform into electrical mm, vehicles. If we can develop a battery which has very high cyclic life, which has very high energy density, etc., and also less costly. Let us see the advantage of lithium-ion battery. Lithium-ion battery has very high cyclic life uh, when compared with other rechargeable batteries like lead-acid battery or other kind of batteries. It has very high energy density. Energy density is very much important, particularly in the field of drones, mobile phones, etc. Drones, the weight of the battery should be low. Then only we can efficiently make the battery as a source of energy for drones. Thank you all.